Good afternoon, everyone. Today's topic is how we can use the geoinformatics tools to study the events like the GLOF. So, whether it is GLOF or floods, they are the natural hazards which are found to occur and also reoccur in the high mountainous regions. So if you have some areas or the human settlements or some footprints which are more vulnerable and you start living very near to the rivers or very near to these glacier lakes in the mountainous region. So in case of the breach of these lakes, the results can be very devastating. So we cannot stop them, but there is a strong option of managing, predicting, and mitigating those risk associated with the breaching of such lakes. So this particular photograph shows the Rambada below the Kedarnath area, where in 2013 there was a heavy rainfall followed by a glacier lake outburst flood due to the breaching of the Chorabari lake. So as you can see, these are the temporary structures, but during the pilgrimage season, it used to be full with the people. So during that disaster, most of the casualties were encountered or seen in this particular part of the river. So this is and these kind of extreme weather events they are associated with the long-term changes in the high mountainous region, the glaciated regions, where we have seen the changes in the glaciers. That is, the big glaciers, they are branching into the smaller ones, and they are retreating. And due to their retreat, the geomorphology and the topography is such that it leads to the formation of the glacier lakes. So this is one example of the Chorabari Lake, where it is one side it is obstructed by the Chorabari Glacier, and one side it is obstructed, or one side it is mountain wall is there. Similarly, extreme rainfall events of the Leh Ladakh also has caused the severe flash floods in the Leh city in 2010. So their frequencies have increased progressively during the last 20 years. And before we move further, so just overview about the basics of the glacial lakes and the glacial lake outburst floods. So, as I told, due to the melting process and as well as thinning of the glaciers and the glacier retreat, so the ice vacates the particular area, and that region is occupied by the water. So most of the time, this particular is the end moraine lake, as it has been seen here, and sometimes it is only the side moraine, as it was the case of Chorabri Lake. So most of these glaciers in the Himalaya, they are retreating by 10 to 40 meters per year. So their retreat, not all the glaciers leads to the formation of the glacial lakes. Only in some few selected cases where the topography and the moraine are in such a shape that favors the formation of the lakes at the end of these glaciers. And global warming and temperature increase, one of the main reasons for the formation of such glacier lakes. So this is the overall distribution of the glaciers in the Himalaya, with Siachen, Gangotri, Jemu, Milam, Kedarnath being the large glaciers in the Himalaya, with Karakoram having the largest glaciers, and smaller glaciers in the central part of the Himalayan region. So this is how a particular glacier will look in a satellite image. And when we say regular monitoring of the glaciers or glacier lakes, it is a remote sensing only which can lead and which can help to map these lakes or glaciers on a regular basis. This one example I am showing for the optical data, list 4 data of Indian remote sensing satellites, resource satellite having 5-meter resolution. So, in case of the severe weather, there is a possibility, and also there is a regular practice now to use the synthetic aperture radar data to map the high mountain glaciers as well as the glacier lakes. So this is Gangotri Glacier here. At the end, this side we don't have the glacier lake, but on the surface here, there are small black spots are visible. Those are nothing but the supraglacial lakes. and this side we have this Kedarnath Valley, this side we have the Gangotri Glacier. So these are the some of the main studies where they have shown the average rate of retreat for the main glaciers in the Himalayan region with range from 7.5 to 23 meters per year. And this is again the compilation of all the main glaciers starting from old times like 1842 to till now. And in India we have this Geological Survey of India, which are the nodal agency, and then we have the university people, research institutes, and the space agencies which are regularly monitoring the snout of these Himalayan glaciers. And as we can see, overall it is a retreat, and the total length change can be as high as 2.5 kilometer to 500 meters in some of the cases. So the bigger glaciers like the Gangotri, Milam, and Pindari, they have shown the significant reduction in their snout, or the retreat of their snout. So, coming back to the lakes, before lakes, there is a regular term that we are using is the moraine. So, moraine is any glacially formed accumulation of the unconsolidated glacier debris. So, here the key word is unconsolidated glacier debris, which is mixture of the soil and rock, and sometimes it is also mixed with the ice, which can occur in glaciated and formerly glaciated regions where you have seen the past glacier maximum. So there are different kind of moraines, the most common being the lateral moraine, medial moraine, and the end moraine. So this particular edge is what we call the lateral moraine. In the when the glacier was moving at its maximum, or the last ice age, so ice was up to this point, but now ice has retreated, so it has edge-like feature is here. And then in the center of this, due to the thinning of the glaciers, this moraine is known as the middle moraine. And this is a typical example of the lateral moraine and also this end moraine. And earlier Kedarnath, what we see now, two separate glaciers, Chorabari and the companion glacier. But if you see historically, this both glaciers are branches of this single main glacier, where ice was up to this particular point. And this is unconsolidated loose soil and rock. So you can see these edges or the walls of the moraines, where during the heavy rainfall there is an internal seepage of the water, and also there is a sheet erosion kind of features which are visible. And if the rainfall intensity is very high, this kind of sheet erosion can also be more severe. And then this photograph is taken from the breaching point where this lake got breached. So you can see this lot of deposition of the moraines in this particular valley in the Kedarnath, and this is the particular temple area. And the glacial lakes, not all the glacier lakes are dangerous. For example, the Sark Lake, which are in the mountainous regions, this is the zone of plucking. Then you have zone of abrasion. So due to the mountain topography, such lakes are very common. Then there are blocked lake. This is the blocked lake due to the mountain topography. Then this is a blocked lake due to the blockage. One side you have the mountain, and one side you have the glacier. So the Chorabari Lake in Kedarnath is an example of the blocked lake. Then we have the pro-glacial lake and this moraine dam lake. This is the most dangerous type, where historically it was part of the glacier, but now it has melted, and instead of ice we have the lake. At the end you still have some moraine left. So it is at the end of the glacier, that's why pro-glacier, and it is also blocked by the moraine. So it is a pro-glacial moraine dam lake. So this is also pro-glacial moraine dam, but here moraine is not continuously, and the lake is not continuously attached to the main body of the glacier. Then you have the supraglacial lakes, which are on the surface of the glacier, which keep on changing their shape and the size with time. And then this is the end lake, where glacier is far detached from the main body, and a lake is further downstream of the main lake. And to map these lakes using the optical data, generally you can use NDWI, or in some cases NDVI also you can use to map them on the cloud-free optical database. So these are the some of the examples of these lakes. So one more category is ice blocked glacier lakes, which are very common in the northern hemisphere and very few in the Himalayan region. So this example B and C. So they are the glacier ice blocked lakes here, where glacier has moved forward, and from the upstream there was a lake, so it has blocked the path of the free flowing water here due to the surging or the natural forward movement of the glacier. So you can see here this particular lake in Kyrgyzstan and Nepal, and one lake here, and then one more lake here, where the main glacier and the tributary glacier has stopped the natural flow of water here. Then we have this landslide dammed lake in Tibet, Nepal region, in the Tar region. Then you have the Moran Dam lake, for example, this particular point. Then this is the Moran Dam lake in the Lahore district, and in the this example, this is the supraglacial lakes in the Dholi Ganga, and in the Bhutan region, you can see the Cascade series of the Moran Dam lakes in the Luge and region of the Bhutan, where we have the series of the lakes. So in the front cover of this slide, I have also shown the Cascade lakes. So they are found in the Trishuli basin. So this is example of cascade of the glacial lakes. One example of the Nepal. This is in the Trishuli basin, where one, two, three, all three are pro-glacial lake, but they are in the series. So there is a chance that if the one lake is breaching, it can lead to the, especially if the upstream lake is breaching, it can lead to the breaching of the lakes in the downstream area. So such lakes are very dangerous for the downstream communities. And this image is from the list score data of the resource set series of the satellite. So GLOF is nothing but the specialized case where a particular glacial lake, for example, this is a typical Moran Dam lake, it will breach and cause the catastrophic discharge of the water from the lake. And it will be two type of breach. It can be the overtopping breach or the piping based breach, and it will cause rapid movement of the water, sediment, and other mixtures in the downstream area, leading to the huge losses of human beings, human infrastructure, livelihood, and agriculture, roads, bridges, and in many cases the hydropower projects. So this is one example of Diktashu in Bhutan, 1994. Which caused major damage to the Namche hydro project. So this is a typical example of a glacial lake and the phenomena with which it can cause the breach. The major criteria for having the high vulnerability of glacial lakes to breaching are large glacial volume, narrow and high glacial moraine dam, stagnant glacier ice within the ice dam, and limited freeboard between lake and the crest of the moraine edge. That means the water level is almost to the top. And these are the some of the triggers which will cause this lake to breach. There can be a calving glacier. Suddenly there is a land mass of the glacier, ice mass of the glacier which is falling, causing the water wave. Then you have the hanging glaciers. In some cases, rockfall also can trigger the breaching of the lakes, or there can be settlement or piping within the dam. There can be melting of the ice core within the moraine, and also a catastrophic drainage into the lake or superglacial cavities. And plus, you can also have the dead ice weighed down by the sediment below the lake bottom, which will stop the subsurface infiltration for temporarily, leading to the increase in the water pressure. And also there is a interbasin subsurface flow. That means two three supraglacial lakes are forming, and then they are draining the large amount. And then one more example of intensive precipitation, because each glacier will have its catchment area or the watershed area. If that watershed area is receiving very heavy precipitation, for example in 2013 the same thing happened in Kedarnath area, so that received very heavy snowfall in the month of summer, and that snowfall will be the wet snowfall, and it will lead to the lot of melting and filling up of this glacial lake rapidly. And once this exceeds the reaches the top, freeboard is very less, the hydrostatic pressure will be very high, leading to the full breaching of this particular lake. So these are some of the criteria which will classify this lake to be vulnerable to GLOF, and also the trigger points. So these are the some of the main characteristics, that they are released in the heavy water, and that is laden with the sediment, ice, and other material. And severity of flood wave, it will depend upon how much water is being released, what is the size of the breach. And discharge generally will vary from 900 to, it can go as high as 10,000 meter cubes per second. So these are again summary how the leak GLOF can happen, either in case of glacier ice dam, moraine dam, or the ice core dam. So this is the one example of the ice dam lake where it has breached and caused the flooding in the this particular area in the North America. So from the geoinformatics, or overall, if you see the space inputs for the GLOF related hazards, the first and foremost input is the digital elevation model. So this digital elevation model will define the river topography or the water carrying capacity just downstream of the river, and also it will help you to quantify the volume of the glacial lakes. So that is very important. And then land use land cover map, snow cover time series map, SAR images, especially during the severe weather condition. Then you have the high resolution images pre and post event, river cross section which will be required for modeling that you derive from the DEM. Precipitation from the satellites can be incorporated in case you don't have the real-time weather station there. Satellite communication in case of the breach, and or if you have installed some early warning system. For example, in Nepal, some of the lakes they are monitored under UNDP project, so their mobile connection may not be available. So if you want to do the immediate communication that lake has breached, water level has increased, so in those cases the satellite communication will be very helpful. Then differential and normal GPS or the GNSS system for the elevation and improving the digital elevation model. And in GIS you can integrate all these data sets, and also use the GIS to generate various input parameters for the hydrological and hydrodynamic models, which will help you to generate the scenarios of the flood inundation due to breaching of such lakes. So starting from the western part, so not just normal Himalaya, the Central Asian regions also, for example, Tajikistan. So there also there has been many cases. For example, this Dust Lake between 18th August 1968, 31st August, there has been a breach of these lakes, and big lakes are formed there, and they have caused the damage in the downstream areas. Then this is the Himalayan region in India. ISRO and the Central Water Commission, which is the nodal agency for all the water related matters, they have the active MOU, and they are regularly monitoring these lakes on the monthly basis, which are greater than 50 hectares in area. In addition to this, there is a water body information system of India also, where up to 5 hectare or even less than that water bodies are sorry are monitored, including the glacier lakes. And the existing glacier lakes map atlas has been released for all the major basins: Indus, Brahmaputra, and Ganga basin, including the transboundary region, using the list for multispectral data under the National Hydrology Project of India. So one is the regular monitoring part on monthly basis, one is the static data where the existing locations are visible. So any lake which will show significant change in the area, and it comes under the criteria of that it is pro-glacial lake, block lake. So those will be the lakes which will be monitored more closely using remote sensing. So this is one example of the lake Gepang Glacier, and then downstream of this one big lake is there, where area has increased to 1 square kilometer, which was 0.144 square kilometer in 1970s, and it has been proven in the published research that if the glacier is ending with the water or the pro glacier Moran Dam lake, the retreat will be faster as compared to the glacier which doesn't have the lake or water at the snout or end of the glacier. So you can see here it is a big moraine here, but fortunately government of Himachal Pradesh in Indian state of Himachal Pradesh, where this glacier lake is located, they have made an artificial spillway which ensures that the minimum drawdown between the top of the glacial moraine dam and the water here remains up to the level of this spillway. So although it is progressively increasing and its valley area is also very wide, there is no immediate threat of big rock slide or otherwise. But still, if some seismic activity happens or very heavy precipitation events happen or very big avalanche happens in the its catchment area, or unfortunately some ice block is there and it is blocking the path of this artificial spillway which is created here. So there are many factors which can increase the water level in this particular lake, and if the water level reaches up to the top of the Moran Dam, that is the time when it can breach. So just to see if the 50% of the lake is breaching, it can generate more than 12,000 meter cubes of the water. So such kind of simulations I will show using the hydrodynamic models how we can do. And then one glacier lake is there in the Uttarakhand region in the Dhauli Ganga, this Bilangna river basin. So this is at height of 4,700 meters. So it is seen as a water only for few months in a year. Rest of the time it will be frozen. But still it is the pro glacier lake, Moran Dam Lake. So if there is a breach, unexpected very heavy rainfall during the monsoon period, it can cause the flooding in the downstream area, especially the Ghansali and other villages, townships which are downstream of this particular lake. Then there is a Safed Tal or the Safed Lake, where it is a block lake. One side it is the Moran Dam Lake, and one side it is the big mountain like the Chorabari Lake, and one side it is fed by the glacier. So here also it is very steep slope. So in case of any big rock fall or ice fall, there can be possibility of breaching of this lake, and then it can cause the damage, especially in the Milam village, in the Milam Valley, in the eastern Uttarakhand region. Then we have this major glaciers in the Sikkim. So these are the different categories of the lakes which are present there. Not all are dangerous. Only 388 which are Moran Dam lakes, those are glacier, plus the pro glacier lakes which are 55 in number. So this is the criteria how you can decide the susceptibility of the glacial lakes for a potential glacial lake outburst flood. So these are the literature available depending upon the area, elevation, freeboard, which is very important. So if lesser the freeboard, more dangerous it is, and if it is progressively increasing, it can cause significant damages. So based upon these criteria and also giving the weightage, and these maps can be generated from the time series of satellite data, digital elevation model. In some cases, high resolution data from the Google Earth can also be used, or you can purchase one high resolution data plus the geomorphological map, and then you give the weightage to these values, perform the analytical hierarchical process to give the relative weightage, and then give the final mapping in the GIS. So this is the influence under the EHP, lake growth, and the highest weightage is given to width height ratio of the dam, freeboard level, seismic and tectonic activity, a distance from the glacier. So these are the four most influencing factors which will affect the lake susceptibility to GLOF. And these are the some of the glaciers where they have shown the high susceptibility. Highest is this particular lake here, which is the South Lohanak Lake, which has progressively increased in size. And then within the Guru Dangmar, the main Guru Dangmar is low GLOF susceptibility. Just but tributary of this and both tributaries are under high GLOF susceptibility and the medium GLOF susceptibility. So although the downstream is less, but if the upstream lake is breaching, it can lead to the cascade of the this one breach. And then we have these tributary glaciers in the downstream, multiple lakes here which have the different levels of low, medium to high susceptibility. So this is one lake where we have the old glacier which has now become a hanging glacier. So this is the downstream lake and this is the upstream lake, and this is the Moran Dam, very high Moran Dam, more than 20 to 30 meters high Moran Dam is there. This is the width of this dam and this is the height. This dam visited by our team, myself and our students in May 2014. And then you have central Himalayan, especially the Nepal region, where we have the largest number of the glacial lakes, which historically have shown the breach and also progressively increasing in the size, especially the Mount Everest, the Sagarmatha area, where you have the highest density of the glacial lakes. So these are the location of these glacial lakes, especially the Dudh Kosi basin. And you can see the 2008 they increased by 9% with respect to 98, and by 2018 it is increased by 2%, and from 509 to 521 square kilometers the total glacial lake area. So this is the Imja Tasho and the Tasho Ralpa glacial lakes where they have progressively shown increase in their area. For Imja Glacier, it is 126% from 98 to 2008, and at present in 2018, it is 1.71 square kilometer. And just for the comparison, the Gepang Glacier Lake area is 1 square kilometer, and it is almost double of the Gepang Glacier Lake. And this is the historical events where GLOF events has actually occurred in the Nepal region. And this is the progress of the glacial lakes in terms of the movie. As with the Gepang, you can see here earlier it was only small glacier, but later on it is continuously spreading upwards in this particular and increasing in the size. Whereas this particular blue one, this is the Sark Lake, which doesn't show significant increase or decrease in the its size. Hello, हाँ जी सर लेक्चर चल रहा है मेरा. ठीक मैं कर लूँगा. हाँ 4:30 बजे. So they are dangerous, and this particular lake is being monitored by UNDP, where is a early warning system has been established along the downstream of this, as well as in the main lake, where lake water level is actively monitored. And this is the other glaciers, Imja, Tashu Rolpa, and Rowling glacial lakes. And some of the, because when this breach will happen, because it is very steep slope, so you may not get the remote sensing data ideally, but these days we have Planet Labs, so daily data, sometimes sub daily also you can get this kind of information very rapidly. But they leave very big scars when they release such a huge amount of water. So you will see very big flood marks, localized landslides, and small debris flows along the pathway of these big GLOF events. Then for the GLOF also, Bhutan also, there are number of glacial lakes, more than 2,600 glacial lakes are there. And out of this, these are the main glacial lakes, 24, which are prone for glacial lake outburst floods. And this is that debris glacier cascade of the glacial lakes which are found in the northern Bhutan region, and they have shown three times the GLOF events in 1957 to 1994. So this is Luge, Thotomi, Luge, and Ras Tharang, and this is the particular final stage bedrock, and this is the present stage. So GLOF will depend upon the how strong is your Moran dam, which is usually unconsolidated, leading to less structural strength. So this is the 3D view of this particular area where we have four glacier lakes in this one, and in the historically 1994 flood event also you can see here. So this is the just snapshot of the that flood event, Luge Lake, this particular Luge Lake flood event. And this is how in the downstream and damages it has caused. As you move downstream, there are a lot of sediment, debris, and in many cases the trees also they will got damaged and they will move in the downstream. And you can see here tree logs being bought in the downstream area, and they cause heavy damage to the bridges and other infrastructure. So you can see here the discharge at the this particular downstream area is 2500 at the downstream, but if you see at the upstream, this discharge will be more than 10,000 meter cubes, because there is a flood routing we call it. There is an inherent channel at the prism storage in the channel, so that will cause the automatic reduction. But if the same kind of event happens in the monsoon season, during the rainy season, the volume of the discharge, it will keep on increasing in the downstream area. So this is the total volume here. Volume discharge from this particular lake was 18 million meter cube. So these are the glacial lakes of Uttarakhand, and we do this simulation mostly using the hydraulic distributed model, because it is unsteady flow and non-uniform. That is changing with the time, changing with the channel section. And from upstream to downstream, there are various methods of routing. As it will move downstream, if it is only the glacial lake, it will reduce in peak, and also the time of travel will be more. And we will solve for gravity, friction, contraction, expansion, wind shear, and other unbalanced forces for the two particular cross sections. And these are the Saint-Vinance equation for the full conservation as well as non-conservation form, which are solved in hydrodynamic model, which are finite element or finite difference based. So each grid time and distance, that is cross section, and the time step will be defined, and at each cross section your water level discharge will be solved. And to get the volume of these glacial lakes, we do the eco sounder survey for getting the depth. To getting the cross section, you can draw the line across the DEM, or you can go to the field and do the actual river cross section survey if it is the shallow water, using the digital level recorder, or using the manual level surveys. It will take time, but it will be more accurate. You may not do it for entire stretch of the river, but few selected points. And the other data you can get it from the good digital elevation model. So this is one example where one glacial lake is there in the upstream of the Alaknanda Valley. In the downstream, we have the six stations, hydropower stations. So this simulation has been done, monsoon, non-monsoon, in the Joshimath area, and this model has been calibrated for the peak flood discharge, and also then the different scenarios at 6 sites for 10-meter breach to 40-meter breach. In the normal case where only lake is breaching, and the other case when the river is in flood, and overtopping of that will be superimposition of the glacial lake. So that case will be the worst case scenario. And in each hydropower points, what is the 100-year plus GLOF water depth if you are designing this hydropower. So your spillway normal flood is 2.93, but if you want to safely pass this flood, so your spillway water depth will be 6.09 meters. And this is example of the glacial lake outburst flood in the Kedarnath region. So here also we have done the detailed post-field survey here, where it was accompanied by not just the glacial lake, but the heavy rainfall, debris flow, and also the breaching of the glacial lake and large damages in the downstream areas. So this is the empty lake and this is the breach point here. And this is the overall flow chart where using the GIS we create all the river database, and then database is exported to the hydrodynamic model, and then we do the full simulation. And if you are using the HACRAS, these days it is fully independent of the GIS. There is a inbuilt GIS component in the new model. You can run independently in the HACRAS 1D, 2D model also, without using the commercial versions of HACRAS, this ArcGIS. Then in the mic, because it is computationally more stable with the better stability, so you can simulate this. You can add the structure where the dam break will happen, and the failure mode can be piping or the erosion based. So in the erosion based, we have collected the data on the grain diameter, specific gravity, porosity, critical shear stats, and what is the final bottom level, final bottom width, and the breach slope of the breach, because we know the final breach. So those data sets were added into the this particular structural module of the Mike 11, and then that simulation was done at different cross section for water level plus the discharge. So 1100 meter cubes per second discharge was computed due to the breach of this particular glacial lake. And then you have two glacial lakes, Padam and Dalung glacial lakes in the Changsha region, where we have seen progressive increase in their size. So that simulation has also been done with the peak flow in at the lake side. It is approximately 3000 meter cube, and in one case it's 4000. And if you go 50 kilometer downstream, it will be reduced to 1500 here and also 1700 here using the one-dimensional hydrodynamic model. The same can be attempted using the two-dimensional hydrodynamic models. So after the 2 hour breach, the maximum discharge in this case, we are assuming this lake area 0.58, volume 15.77 million meter cube, and mean depth is considered approximately 10 meter. But this depth will be verified when we actually visit this particular area, and then we will get the better estimate on the volume. In case of Kedarnath, entire glacier lake was empty, but same may not be true for all the glacier lakes. So it will depend upon how much is the breach of the glacier lake. If it is going up to bottom, then entire lake will drain, damage will be more, peak discharge will be more. If it is only partial breach, then only maybe half of the lake is breaching. Then this is the Chukda Lake in the Bhutan region, where it has a substantial increase in its size has shown in last 30-40 years, and it is 1.53 square kilometers as of now. And the same different criteria at different return period hydrographs were generated, assuming various lake depth and also time of the breach. So in the downstream of this, there is a airstrip and village also, Jakar village. So based upon the simulation that the lake depth is 20 meter and it is breaching in 40 minutes. So it is showing that this particular airstrip probably will be underwater if there is a breach of this particular glacial lake. Apart from the glacial lake, there is a cascade of the events also. For example, there is a glacial lake here, Nila Tal glacial lake, and then there is a this is a kind of supraglacial lake. But later on, due to the retreat of the Gangotri glacier, the side wall is having lesser support. So the drainage channel started developing here in 2016. By 2017, there was a big rainfall event here, precipitation event, so which led to the formation of this debris flow. So you can see here big debris flow event happening, and the satellite capturing the mixture of slurry water mixed with the sediment a few days after that event, and then using the time series of the DEM before the breaching and DEM after the breaching, we could quantify how much was sediment was eroded and deposited. And fortunately, there is no human habitation few kilometers downstream of the main snout of the Gangotri, so there was no damage, human or structural damage in the downstream, and there was no also permanent formation of the glacial lake. So this shows the remote sensing, continuous monitoring using remote sensing. As you can see here, 2016 November, the initial debris, this water flow has started, and that was fully breach was seen in the next season in the July of 2017. And temporarily it led to the blockage. Then the river flow from the center line, it shifted to the right side, that is more towards the northwest side. And one more event which is unique, earlier when the Chamoli event happened, many people said it is glacier lake outburst. But later on, based on our inventory, there was no critical glacier lake. So this is also a very unique event, which due to the very high mass loss due to the rock slide and very high energy generated by the this rock mass mixture of ice, snow, it was melted instantaneously, caused the huge water wave to come downstream area. And due to the topography, geomorphology of this particular area, this area has seen, because it is turning by 90 degree, so the maximum water rise was seen at this particular area. And this landslide also breached and also blocked the main river, Nanda Devi side river. So where there is a small glacier lake due to the this particular landslide and the debris flow has been reported. So this caused the flooding. Then in 2000 and 2005, there was a big landslide induced glacial lake which breached and caused severe flooding in the Satluj valley. So this is the photograph of that. So not just the glacial lake, but the landslide induced lakes and their breaching also causes severe damage in the downstream area. So remote sensing helps you to monitor such glacial lakes, and combination of HD model will help you to generate various scenarios for such kind of cases. So in India, we had this dedicated guidelines under National Disaster Management Authority, which I was also apart from other leading hydrology, geological departments of Government of India and IITs, NITs, SASE. So they have come up with this particular guidelines, what to do, what not to do, how to monitor, what kind of research to undertake, what kind of SOPs to be followed. So this is publicly available. So any of you, they can go to the this particular website, and not just the GLOF guidelines, all disaster related, whether flood, cyclone, heat wave. So those kind of guidelines you can download from the NDMA website. So with this, I complete my lecture.